All right, let's get started. All right. All right. So we're going to go to page 2 of this AP Calculus review. And what I'm going to do is I'm going to work these out on my Elmo again. And so let me kind of walk through page 2. This is a review of systems. And so the directions say solve each system by graphing. Make sure each equation is in slope-intercept form as y equals mx plus b. We just did that in the previous activity, but we have to change these standard form equations. Like the first equation is in standard form. So we have to get it in slope-intercept form. Well, that's simple. We're going to simply move 2x to the other side of the equation. If we move it, it becomes negative. So it becomes y equals negative 2x plus 2. And the bottom equation is x minus 4 is already set up, and the slope is 1. So if we review how to graph these, this is simple. My slope in this problem is, in the first one, is negative 2. So that's really negative 2 over 1, which means I'm going to go down 2 and write 1. In the bottom equation, my slope is 1 over 1, so that means down 1, right 1. And the 2 represents where I start. So my y-intercept is at 2, so I'm going to put a point there at 2. And my slope is going down 2, right 1. So 1, 2, down 1, put a point there. I can do the same thing, down 2, right 1, put a point there, and do the same thing and follow that pattern to get the rest of these points. I can go the opposite way, up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. And so if you notice, I make a line. So my line is right here. That's the first line. This is y equals negative 2x plus 2. Let's graph the second line right here. I know I'm at negative 4, 0, 1, 2, 3, negative 4. And my slope is to go down 1, right 1. So from here, go down 1, right 1, right here. Y-intercept is at negative 4, down 1, right 1, 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 right here. Go the opposite, up 1, left 1, up 1, left 1, up 1, left 1. So we can clearly see that if we follow this pattern, here's our line right here. And they intersect at 1, 2, 3, 4, 5, 6, and negative 10. So the intersection point is at 6, negative 10. That's the intersection point. That's the solution to the system. Now, if you want to prove it's right, because they said check your answer, plug them in. So x is 6 and y is negative 10. So if I put 6 here, this first equation, I put negative 10 here for y, 2 times 6 plus 2. Does it work? Negative 10 equals negative 12 plus 2. That's true, it does work. So the first equation is good. Second equation, negative 10 is your y. 1 times 6 . Hold up. Hold up, I made a mistake. Oh my God, it's a great. I'm glad I do the math. This line is wrong. You know why it's wrong? Because this is a positive slope. I should have been going the other way. So if I was here, it means I should have been up 1, right 1, up 1, right 1, up 1, right 1. So that means in reality, see, that's why you check your answers. So my answer is wrong because my line is incorrect because it should have been a positive slope. And I made a mistake. I apologize for that. Here's the correct line. So here is the point. The point is at 1, 2, down 2. So the solution is not 6, negative 10, but it's 2, negative 2. So let's go back and plug in and see what happens. So -2 times 2 plus 2. And let's see if we get -2, because remember the y is -2. So this is -4 plus 2. That equals -2. That does work. So for the first equation is good. Second equation, -2 equals 1 times 2 minus 4. So -2 equals 2 minus 4. Is that true? Yes. So the answer is not 6, -10, but it's 2, -2. And it's easy to make that mistake. And I'm glad I saw my mistake, because I graphed along, I went up 1, left 1. It should have been up 1, right 1. And I'm sure you caught that, but I caught the mistake. So when we did the solution, it didn't work. So we can clearly see the solution was 2, -2. All right. So let's practice a problem with substitution. We're going to try number 3. Okay. Remember, with substitution, the goal is to find a variable that's isolated. So notice that the y's are isolated, but I'm going to go with the positive y because it's positive. So I'm going to isolate the y by bringing 2x on this side of the equation. So y is going to equal to 10 minus 2x. 2x is positive, on this side it becomes negative. So this is my solution. So this y, I'm going to plug in. This number will go right here. So I'll have 4x minus, in parentheses, 10 minus 2x. I'm using those parentheses because of this minus sign. This minus is going to change both of these. Equals 2. So if I do my algebra, that's going to be 4x minus 10. The negative with this negative becomes positive. Equals 2. Combine like terms. 4x plus 2x is 6x. Minus 10 equals 2. Minus 10 comes, 2 comes. Add 10 to both sides. 6x equals 12, x equals 2. So we know x is 2, so we can take the x and put it right here. So y equals to 10 minus 2 times 2, because x is 2. So this is 4, so 10 minus 4 is 6. So y is equal to 6. My solution is 2, -6. So if you want to check your answer, you can plug in x and y. If I put 2 here, it's not -6, it's +6. So 2, 6. So if I put 2 here, what's 2 times 2? 4. Put 6 here. 4 plus 6 is 10. That checks. Let's come here. What's 4 times 2? 8. Put a 6 here and there's a minus. What's 8 minus 6? 2. It checks. You can plug it in and make sure it works. All right. Final example on this page with systems. Okay, here we go. All right. I'm going to try problem 5. 5 looks a little bit more challenging. So I want you to notice something about 5, that you have an x here and a y here, but you can't add the systems and eliminate. So what I'm going to do is I'm going to multiply the top equation by -2. So that gives me -2x minus 2y equals 2, because -2 times -1 is +2. 2 times x is -2x, -2 times y is -2y. 2x plus 3y equals 0 on the bottom. These cancel because you're adding these two systems together. So -3 plus y, 3 plus -2 plus 3 is 1y. 2 plus 0 is 2. So we know y is equal to 2. And we can just take 2 and plug it in right here. So x plus 2 equals -1. I want to subtract 2 from both sides. So my x ends up being -3. So right immediately, if I plug in -3 for x and a 2 here, -3 plus 2 is -1. That checks. If I plug in -3 here, 2 times -3 plus 3 times 2, do I get 0? This is -6, this is +6. Negative 6 plus 6 is 0, it checks out. So when we do the solution, we find out that our solution is negative 3 and 2. So that's our systems. I'm going to stop right there and look for you on page 3.